Hello everyone to this Keptn maintainer track session. Today we'll talk about the matrix operator. My name is Thomas.
Hello everybody, my name is Florian.
Yes, and in the last few weeks we created some things around matrix which could make your life easier, and we wanted to show you what's in there. So at first, what's the problem with matrix in Kubernetes? Many of the components we have in Kubernetes need some metrics, such as the Kubernetes HPA, such as Argo rollouts, also Flagger, and so on. Almost every component needs its own provider. So every component we discussed before needs some kind of code which communicates to an observability provider. This code needs maintenance. And what we thought as a Keptn team was, what if there were a single metrics provider in a Kubernetes environment? So that you only install one component in your Kubernetes cluster, which provides the metrics to you, which also has all of the observability providers in there, and you can simply query this. And yes, Florian, show us how this works like.
All right, I'll be glad to do it. All right, so recently we have introduced our new Keptn metric operator. And the way this works is that you can define your metrics that you want to observe as custom resources, which are then being reconciled by the operator. In these custom resources, you will find an example later in the demo. Basically, you tell which provider you want to get those metrics from, and what query to use to fetch the metrics from the respective provider. The provider points to an observability platform. So the ones we currently support in the metric operator are Prometheus and Dynatrace. And then once the Keptn metric has been applied, the Keptn metric operator will go to the defined observability platform and retrieve the metric values using the query that you provided. Once it has a value, it will update the status of the Keptn metric custom resource, and there you will be able to inspect the value that you got. And in addition to that, the metric operator will register itself to the Kubernetes custom metrics API. And that means that you can make use of those metrics, for example, in a Kubernetes horizontal pod autoscaler by referring to the Keptn metric objects in your HPA definition. And yeah, that's the theory behind that. And let's jump over to my IDE, and we're going to have a look at an example. So we are now in Visual Studio Code. And what do we see here? So first of all, we have our deployment of our Potato Head sample application. So that's our demo application that we usually use when showcasing stuff in our Keptn Lifecycle Toolkit. A very simple microservice-based application that we're now going to deploy, right? So let me do just that. So we are going to apply the deployment. And now everything is being created. And let's jump over to our lens. And as you can see, we have our deployments here and the pods, right? So far, so good. And now we would like to, let me close all that. We would like to get metric values for our deployments, right? And for that purpose, we are going to apply a Keptn metric, which will represent the CPU throttling that happens for our deployments. And yeah, so this will be deployed into the Potato kubectl namespace, which is the same namespace where our actual application lives. And we want to get our values from Dynatrace using the following query, which represents the CPU throttling for the pod that we are running for this application. So maybe one thing, what is a provider? So the provider tells you where to get those metrics from. Let's have a look at an example. So here we have our Keptn metrics provider with the name Dynatrace, which is being referred to in the Keptn metric. And this will point to your Dynatrace tenant in that case. And obviously you will also need an API token, which you can refer to by including a secret that contains the token. All right, and now let's deploy our metric. So, all right, so now our metric called CPU throttling is created. And to see if everything works, let's go back to Lens. And here in the custom resource section, you will see the Keptn metric, which are part of the metrics.keptn.sh API group. And if we click here, we will see that the metric is applied. And yeah, now we also get a status. So right now we have a value of 1.36 for our CPU throttling for that. All right, so now we have the application and we have a metric. And now we want to act upon the status of this metric, right? And for this, we have prepared a horizontal pod autoscaler, which again will be deployed into the same namespace where our application lives. And in this case, we want to scale our potato head entry deployment. And we want to scale that between 1 and 3 replicas. So right now we have 1 replica deployed because that's the original value from the deployment that we applied earlier. And now we would like to decide whether to scale up or down based on the value that we get from our metric. And for this, you first of all define the name of the metric that you want to observe. And here in the described object section, you can refer to the Keptn metric custom resource that we just applied. So in that case, we want to inspect the CPU throttling, and ideally, we would like to achieve a value of 1. So when scaling up, this value should decrease over time. And if you recall earlier, the value was 1.3. So in theory, as soon as the horizontal pod autoscaler is applied, it should do its job and scale up the potato head entry deployment. So let's just do that. -F. We want to apply our HPA. All right, so now that's created. And what I wanted to show you as well is, in the meantime, until this is running, we can also get the metric values using the kubectl raw command. So here I've provided an example command in the make file, which basically executes the kubectl get raw with the path to the custom metrics API. And as you can see here, this is another way of retrieving the current values of our metrics. And now let's check the status of our horizontal pod autoscaler and see how it's doing. So as you can see here, all right, so we can see that everything was wired up correctly because it was able to get the value of the CPU throttling metric. And based on that value, it was able to calculate a new replica value. So if you go back to Lens into our pods section, we should now see that we have 3 replicas of our potato head entry service running. And over time, hopefully, this should have the desired effect of decreasing our CPU throttling metric. And yeah, so that's everything that I wanted to show you for this example. So let's go back to our slide deck and recap real quick. Yeah. In addition to what we've showed you now, so we've shown you how you can make use of these metrics in the horizontal plot autoscaler, but we want to make this as flexible as possible. And by providing these metrics as part of the custom metrics API in Kubernetes, you could, for example, also make use of those in tools like Argo CD, or also in Keda, or maybe even Flux, or in Keptn version 1. So with this nice unified approach of registering ourselves at the custom metrics API, we think this is a very powerful and flexible way of aggregating metrics from different providers and making them accessible in a unified way. And as I said, right now we do support Prometheus and Dynatrace, but of course, being an open source project, we always look forward to receiving also external contributions. So right now, for example, there's also a Datadog provider in the works right now. And of course, if you would like to add your provider, you are more than welcome to contribute, and we're happy to get in touch with you and look at your proposals and pull requests. And with that, I would like to hand back to Thomas.
Yes, thank you, Florian, and thank you for this really awesome demo. What can you do to make the matrix operator better? At first, just try it out. So install the matrix operator, install the whole lifecycle toolkit if you want, play around with it, try it out. And if you find some issues, hopefully not, or if you find something which we could make better, feel free to raise issues or pull requests or whatever. Furthermore, if you know any observability provider which is currently not implemented in the matrix operator, you can write your own provider. So for Dynatrace and Prometheus, I think it was about 40-50 lines of code, right, Florian?
Yeah, pretty much, yeah. So really simple, actually.
Yes, so it's not the big rocket science, and it would bring a lot of value to the Keptn matrix provider to the Keptn matrix operator, if we have much more providers. Therefore, feel free to raise a pull request for that. Yes, as we said in the previous slides, you only need one integration for every component to get to many observability providers in the end. So if you know any tool which might benefit of some integration in the Keptn matrix operator, sorry, feel free to write this integration. There are at the moment, I think, 2 ways to integrate. So via the Kubernetes matrix API, we also wrote our own API. So there's enough integration. There are enough integration points for everyone. Therefore, feel free to do so. And yes, let's make the consumption of metrics in Kubernetes easier. So with every contribution you make to this project, I think we are making the life of many people much easier. And yes, it would be awesome if this would get a bit larger. Yes, the last famous last words. Sorry. How to get in touch with us? So at first, link and star us in the Keptn Lifecycle Toolkit repository. So if you try it out, if you try out the lifecycle controller itself, if you try out the matrix provider and you think this is a very awesome project, feel free to spread the word around it, star us, and so on. You can also share your thoughts. So if you want to see some feature in the Keptn Lifecycle Toolkit or in Keptn itself, raise issues and talk to us on the CNCF Slack. And in the end, you can always reach out to us, as I said before, on the CNCF Slack, on via pull request and so on. And you find us in the Keptn Lifecycle Controller Development Slack channel in the CNCF Slack. So we hope that you enjoyed this session, and hopefully you will have a lot of fun with this. Thank you and bye-bye.
All right. Thanks, everyone. Bye.